Hey everyone, and welcome. So I want you to think about something you've probably never given a second thought to, a simple bag of chicken feed. It doesn't seem that exciting, right? Well, let me tell you, inside that bag is a world of absolutely fascinating science. Science that impacts everything from the health of the animal to the environment, and yeah, even the price you pay for chicken at the store. Let's get into it.
Okay, let's start with a number. If you're a farmer raising poultry, what do you think your single biggest cost is? The land? The barn? The birds themselves? Nope, it's this. 70%. But 70% of what?
You guessed it, the feed. For most farmers, feed makes up a whopping 70% of their total production cost. And that's a huge deal. It means that any little improvement, any way you can make that feed go further and be used more efficiently by the chicken, has this massive ripple effect. It helps the farmer's bottom line and can make food more affordable for all of us. But, of course, there's a catch.
And that catch is what we're calling an indigestible dilemma. It's this core problem that scientists and nutritionists have been wrestling with for a long time. And it all comes down to a really simple question.
I mean, it seems pretty straightforward, doesn't it? A chicken eats, its body digests the food, it pulls out the nutrients, and it grows. But it's not nearly that simple. A really significant part of what they eat, especially in feeds made from common grains like wheat or barley, is basically indigestible. And the culprit behind this has a very specific, kind of complicated name.
Let me introduce you to the villain of our story, non-starch polysaccharides. You can just call them NSPs. Now, think of these as the tough, stringy, fibrous parts of a plant's cell wall. They're a totally normal part of grains, but here's the problem. A chicken's digestive system just doesn't have the natural tools to break them down. And when these NSPs don't get broken down, they start to cause all kinds of trouble.
What happens is this crazy chain reaction. Once these NSPs get into the chicken's gut, they just soak up water and form this thick, slimy gel. They basically gum up the works. This gel then physically traps good stuff, like proteins and fats, making it impossible for the chicken to absorb them. This, in turn, makes the bird thirstier, so it drinks more water, which leads to wet, sticky droppings and really poor hygienic conditions in the barn. It's a huge mess. But every good story needs a hero, right?
And our hero comes in the form of something we can think of as nature's own molecular scissors. See, the solution isn't to get rid of the grains, but to give the chicken the exact tool it's missing to unlock all the good stuff that's already in there.
And we're talking about enzymes. You've probably heard of them. Enzymes are these amazing little proteins that act as biological catalysts. The best way to think of them is like tiny scissors that are designed to cut only one specific thing. They find their target, snip it apart, and then move on to the next one, completely unchanged.
Now here's the key distinction. Chickens already make their own enzymes. Those are called endogenous enzymes. They use these to break down fats and proteins, no problem. But, and this is the whole point, they do not naturally produce the enzymes needed to cut up those tough NSPs. That's where exogenous enzymes come in. These are the special scissors that scientists can add directly to the chicken feed.
Which leads to the next logical question, right? If enzymes are like super specialized scissors, you can't just toss in any random enzyme and hope it works. You have to perfectly match the right pair of scissors to the right kind of fiber you're trying to cut.
And this is where the science gets really cool and precise. If the feed is mostly barley or oats, you need to add an enzyme called beta-glucanase. If it's mostly wheat, then you need xylanase. Then there are others, like phytase, which we're going to come back to in a minute because it's a real game changer. The bottom line is, by knowing what's in the feed, nutritionists can create the perfect enzyme cocktail to take it all apart.
So what happens when you do that? When you add these perfect little molecular scissors to the mix? Well, you don't just get one benefit. You unleash this incredible cascade of positive effects that solves every single problem we just talked about. Remember that thick, nutrient-trapping gel in the gut? Gone. The enzymes slice up the NSPs, and the gut is no longer viscous. And just like that, all those trapped fats and proteins are set free, so the chicken's own natural enzymes can finally get to work. The result? The bird gets way more energy and nutrients from the exact same amount of food. This means better weight gain, a much better feed-to-gain ratio, and just a healthier, happier bird overall.
And this is why it matters to everyone, not just farmers. Healthier animals mean we're producing food more efficiently and more sustainably. When we can get more nutrition out of the resources we're already using, that's a huge win for the whole food system. But believe it or not, the benefits don't even stop there.
Because this same technology has another massive positive impact that goes way beyond the farm and into the wider environment. And this is all thanks to that one special enzyme I told you we'd come back to.
Let's talk about phytase. You see, most of the phosphorus in plants is locked up in a molecule called phytate, and just like NSPs, it's totally indigestible for a chicken. This means two things. Farmers have to add extra phosphorus to the feed, and all that unused phosphorus from the plants just passes right through the chicken and ends up in the manure. Phytase is the special key that unlocks the phosphorus that's already in the feed.
So what kind of a difference does that make? Well, the impact is, frankly, staggering. By simply adding phytase to the feed, you can cut the amount of phosphorus the chicken excretes by as much as 40%. And a 40% reduction is a really big deal. When you have a lot of poultry farms in one area, the excess phosphorus in manure can run off into streams and rivers, causing major water pollution. It leads to something called eutrophication. You've probably seen it, those huge, dense algae blooms that suck all the oxygen out of the water and harm aquatic life. So by helping a chicken digest its food better, we're literally helping to keep our rivers and lakes clean.
So when you put it all together, you have this amazing win-win-win. It's a huge win for animal welfare because the chickens are just healthier. It's a huge win for the environment because we're cutting down on pollution. And it's a huge win for economic efficiency for both farmers and consumers. It's just a stunningly powerful piece of science. So where do we go from here? I mean, this technology is already incredible, but this isn't the end of the story. The journey of feed enzymes is actually a fantastic example of how science is always pushing forward.
Think about it. For a long time, we just knew there was a problem. Then, the big breakthrough came in the 1980s, when it became possible to actually produce these enzymes on a commercial scale. Now, they're a standard, essential part of the toolkit. But the next frontier, what scientists are working on right now, is all about getting even more precise, perfecting those enzyme cocktails. And the guiding principle behind all of this research is really clear. As these researchers put it, it's not just about efficiency for its own sake. The ultimate goals here are to improve the welfare of the chickens, reduce waste, and conserve our precious resources.
And that leaves us with the final, really exciting question for the future. You see, not all wheat is the same. Its nutrient makeup can change from one field to another, from one harvest to the next. So the next great challenge is this. How do we create the perfect, custom enzyme cocktail, not just for wheat in general, but for this specific batch of feed? It's a fascinating puzzle, and it just goes to show you that even in a humble bag of chicken feed, there is always more to discover. Thanks for listening.